did any of your clients reported to you guys that your application are taking too much memory or something like that? You need to debug this stuff?
Never.
Never. All right. That's cool. Obviously. But, well, it happened to us, but we also monitor this, and we have to deal with this in our CK editor. And that's why I'm here to you to talk and share my experiences with debugging the memory leaks. Let's hide it. As a quick introduction about memory management in JavaScript, as you should probably know, in JavaScript there is no need for a manual handling of the memory. The JavaScript engine will do this for us, and the whole process of memory lifecycle is pretty straightforward. You allocate the memory when you start using some variables, then you use it, and the memory then is released, and the garbage collection is the process of automatically freeing the memory when the objects that you are allocated are no longer needed in your application. Going through all the steps of the memory lifecycle, we can start with the allocating memory. This process happens when you have the initial declaration of the primitive values, when you are starting using object and array. It also allocates the memory for the contained values. When you declare some functions, then the callable objects are also allocated for you by the JavaScript engine. Also worth noting is that when you are creating DOM nodes or using array or script function, the memory also is allocated then. But you don't have to worry about it because the JavaScript in most cases is handling this for you, so you don't have to worry about it. And next step is just using the memory. So everything what your application will have to do with your objects. And after that, when you don't longer needed the object that you created, the memory is released. And the important thing is here that how or when this process happens. So the garbage collector will find those objects that are no longer needed by your application and will free this memory for you. But there will be a question, how the JavaScript engine know which objects are no longer used. So all modern browsers will implement the mark and sweep algorithm that will detect the objects that are no longer needed by finding the unreachable objects. And those sorry. The unreachable objects are those ones that are no references by any others. The marker sweep algorithm defines the known routes, so-called garbage collection routes. There are like global objects like a window or a console, and going from the root to it finds all the variables that are referenced from that global object. Now, then checks objects that are referenced from there, and so on. It will mark all the objects that are still references back down from the root, and all those objects that are not referenced directly to the or indirectly to the root are considered as unreachable, and then those memory can be freed for them. As for now, there is no way to manually call the garbage collection. The garbage collector must to stop the application to find those objects. So if you do something memory intensive, you can notice some lags that when the garbage collection is actually happening. So if you are talking about the memory leaks, we have to know when those leaks happens and what are actually the memory leaks. So the memory leaks are actually the objects that are referenced from the still referenced from the garbage collection routes. So you can reach them, but your application no longer needed them. So from the perspective of the whole applications, this is called a leak, and this is the memory still occupied, which could be freed, but because there are references back to them from the global window, the garbage collection algorithm cannot free this memory. When this happens, well, basically it happens first of all if you have something assigned to the global root, like to the window, it will be still there until you dereference it. All the forgotten event listeners or some callbacks that have context back to the other objects referenced, but detached DOM node. So if you created the DOM node and then you remove it from the DOM, but you still have the reference to it, it will be occupied. It will occupy the memory. And also all the variables that are not needed but are shared by the lexical scope of closures. We'll talk about this later. So all the objects that are not needed but are still referenced are your memory leaks. If you want to find what causes the memory leaks or the growing the application's memory footprint, you have many tools, but most common of them will be the tools available in the browser's developer tools in the memory tab. If you need to check something programmatically, there is also the performance memory object, in which you can find read programmatically from your program what is the used heap size. So what your application right now is using, how much memory is using. And one important thing before you start actually debugging the memory, finding the leaks or what's happening in there, is to disable all the plugins when you are running your browser, because all the add-ons and extensions will be also reported in the memory profiles, so they can shadow your actual results and also be may cause some leaks in the application. Okay, sorry. If you go to the Firefox DevTools, you will see that actually they are not quite that useful. Actually, at least for me, because in the Firefox they don't tell you as much as the Chrome DevTools. So I really don't use the Firefox DevTools. The only nice thing is that you can actually see the retention tree, so how the objects are referenced. But to see this, you need to tick the record call stacks, because if you don't tick this, you will not see any actually values that or where this leak is happening in your code, you will have only reported the objects and their IDs, but nothing else. And this is not very useful. Much better tools are available in Chrome. In Chrome, actually, even the first the empty profile page will have a good explanation about the tools, what they are doing. The most useful are the allocation timeline profile, in which you will see how the memory is allocated and used on the timeline. You can then select some time frame in there and detect what happened there and why there are some memory used. I will show how to use it, of course, in a minute. And the other thing is, which is pretty useful, it's taking a snapshot of the memory, so you can check your application at one stage, then, for instance, unload your module that is causing memory leaks, take another snapshot and compare them. The very nice thing here is that you can filter your results, the objects that are occupied still in the memory, by a class name. So you can see, for instance, if you know that one object is should not be there, you can filter for that. And also in this window, you'll see that when you are compare the two snapshot, how many objects there were allocated, how many were deleted, what is their size, and when you gonna inspect the objects that are still in memory, you will see, for instance, the distance. The distance is the how many references are there back to the root, garbage collector root. Its shallow size. The shallow size is the object alone. So, for instance, if this is just some class object, it will be a very small memory footprint. But if there are any other attributes in this object, there will be reported here as a retained site. So the object here is very small, but their properties are around almost one megabyte. And another important thing, if you are looking on these reports, is looking for the blue ones, because the blue ones are showing you the reference which is causing the retention of your object in the memory. So let's go to some live debugging and see some demos. This is the first example of memory leak. It's accidental global. You can create a global variable by assigning something to window, but not writing any const or var. It will be also attached to the window, but also using this when you are not inside any class. This also will be retained on the global object. And will be reported as, and it will be retained in the memory. Oh, not this. So, let's see how to use these tools. Okay, so with the accidental global, I will show you how to use allocation instrumentation on timeline profile. Sorry, I will start. Right now, nothing happens. No memory is allocated. If I call something, you can see that the tick. The tick is when I create a global variable, and every time I allocate some memory, the next tick is happening, and the gray ticks are the memories that is freed, and the blue ones are the memory still occupied in the object still occupying the memory. And as I said before, you can check interesting time frame. You can see the in this window what memory are there, what objects were allocated. You can see that there is the big object, which is it will be not shown in this demo. Sorry. Okay, I will try to use the touchpad. And you can see that this object is still occupying the memory. Let's clear this one. So this is the allocation timeline. And this was this example because this object was attached to the window. Another example of things that are causing memory leaks are situation where we are passing some object to another method. Thank you. And you are passing basically too much. And the big object is also referenced somewhere. So to illustrate this, I will let's clear this. You can see that this object is not cleared. Oh. I know that this is a big object. I can search for this one. Okay. So I found that here that this big object instance is still occupying the memory. And if I go to the returner's view, I can inspect what causes the memory leak. So why this object is still referenced in the by some other variables, and I see that in here it is retained by a config. Retained by config and in big object property. This is something to avoid, that when you are not needing every property from object, it is better to pass only the values that are needed. And to show you intermediate. Okay. Sorry? I cannot. Because this is all right. No, I can't hear. Okay. Basically, if you pass only the values that are needed to your method, it will no longer be retained in the memory. I don't know if I can show this. Ooh. Hopefully I will. Nope. I didn't. Okay, sorry. So this I probably don't do this very good. But passing only the values that are needed from the other objects that are referenced somewhere else is a good idea. Now, this example comes from a Meteor blog. In in here is something that is not so obvious on the first side, because what is happening here? So the function replace thing, when it is called, saves the previous reference to the thing. Now it defines the method unused, which is supposed to do something with this reference on the original thing. This function is never used anywhere, so you might think that this reference also shouldn't be needed. And after that, the new value is assigned to the thing, where there is some properties and other method, which actually doesn't uses any other things from the scope. So if you look at it, you might think that JavaScript engine should be clever enough to detect that the things from the closure shouldn't be used anywhere. But actually, because even though the method is not called everywhere, it's creating the same, is using the same lexical scope with the another function, with the second function, and on the subsequent calls to the replace thing, we keep the reference to the previous one, to the previous methods defined here, and I will show you on the demo. Let me refresh. Maybe timeline. So even though the method is not used, it is still keeping the reference to the previous values. Closures. And every time you are where you are calling the replace thing method, you will be keeping references to the previous one. And if you check how the very first big object created is referenced. Oops, sorry. I hate typepads. Let me show you this. So in here, the retaining tree for the first created context is passing the references to the previous one, and this loop is the references are created on each subsequent call. But this is very unexpected result, but probably it is best avoided using any linter that will show you that this method is unused and it should be removed. So also not removing anything what is unneeded from your code is also a good idea. Mm-hmm. Some other examples of things that can cause these problems are any nodes that are created, like I said before, and are referenced. Any detached DOM nodes which are only removed from the page, but the references are still there. Any intervals that are using variables from the closure, and something that is actually happens in the support tickets, that our client was telling us that our application was causing the memory leaks. He has the console log in the application, in the snippet, and you might be surprised, but also logging something to the console will cause the memory leaks. So let me clear this one. Oops, clear this one. Console log. So as you can see, I just logged some object to the console. If I go to the memory profile, I will see that something was allocated. It is still there in the memory. And logging some objects to the console can also show you that the memory is still retained, because the console gives you another garbage collection route. If you clear the memory, we tried. Oh my god. You will see that the previously allocated object is freed from the memory. Let's go. Got and stuff. Okay. So to sum up, to avoid memory leaks, you have to be careful with anonymous functions and callbacks. What you are passing to the scope of the functions. Pass only those objects that are really needed. Don't pass big objects. Pass only the values. Deregister any unused callbacks, like event listeners for buttons, for clicks, if you don't gonna use them, and you need to use named functions for that. Consider using weak map and weak set if you are mapping some values that you are not capable of tracking when you are creating and destroying them. They are very useful for that. Remember that garbage collector must pause execution of your application to collect memory, measure, and when testing, disable all add-ons. And as a bonus, you can start Chrome with special JavaScript flags to expose the garbage collector. We actually tried to use it in our automated test with even some success. We could, back in January when we were doing this, we could have karma tests that were detecting memory leaks. But in recent versions of Chrome's, we stopped using this because I think that they changed something in this method and it is no longer as good as it should be. Okay, thank you.
Thank you very much for delivering this talk timely. Are there any questions? To Maciej?
Yeah. I think it's more than comment than question, because I think that the console can still have a reference to some object if you are opened DevTools. Do you check that? Because it's safe to call console logs with objects if you're not using DevTools, like whatever.
Yeah.
If you have on production some console logs, so it's only when you develop something and you have open DevTools and then you console log something that it still will be in memory.
Yes. But it's somehow like a Schrödinger cat problem that when you don't open console, then you don't know if it's there or how to check it.
Yeah, but I mean that if you have a problem on production, it's not this.
Yeah.
Because it can be like your users open DevTools and have memory leaks.
Yeah.
I suppose that they don't do that.
Yeah.
Nice, there's agreement on that. Next question.
Would you mind making the demo page available on GitHub?
Yes, it is. Yeah, it is linked in the presentation. If you go to the presentation link,
oh, wonderful! I didn't see that.
It will be in the 10. There are also comments in the code, I think, and all the different buttons have.
All right, that's great. I never really understand how closures work, so that's. I'd like to play with that a little bit.
This problem is a very curious one.
I'm also asking people on YouTube if they have any questions so they can actively participate, but I can see that there is one.
So my question is, assuming that I do front-end development, should I even care? Like, usually you don't keep too much data in the memory anyway on the front end, and the application is rather short-lived. And also, we shouldn't pre-optimize, and you left some bunch of pro tips, but some of them would make code a little bit uglier or harder to understand if they would be, always used, right? And my question is, what's your rule of thumb, and perhaps tools for monitoring of front-end applications? Because with Node, it's totally different way. It's totally different word, but yeah, what's your take?
Well, it depends. If you're creating an application and it's living from all the way when the user are using it, it's no problem. But it happens, for instance, when you are dynamically loading something and then hiding from your application some parts. Like in our case, it's the editor. It's not always needed, so users can create it and then destroy it. And in this case, if you will create the editor multiple times on the one user session when you're on the page, and the editor itself will be leaking the memory. So on each create and destroy cycle, it will be still in the memory. Each new editor created, you will the page can slow down because you are still using much memory. For instance, in CK editor, if when we had this problem, it was like the one editor without big document was like 20 megabytes or something. So if user were creating and destroying many instances of it, you can imagine that the memory will grow very fast. And the other questions was about
I guess monitoring of these
monitoring. Yes, basically opening the DevTools when you are running your application, you will see this. Let me go to this. Clear. Nope. You can here see how much memory your page is using. Obviously, it's not for the production, but when you are developing your code. For productions, basically you could have some using the Windows performance memory. You can read this and save it or something like that, but I don't have any tips for that.
Okay. One last question. Sorry, guys, because we're on time.
Thank you. I have a question. So what do you think about service workers? And is it also useful? Because as JavaScript is single-threaded, event-based programming language, then do you think is it also useful for debugging memory leaks? If may they occur when you are using service workers?
I haven't used service workers that much to tell you. I think that probably they will have different contexts, so different garbage collection route, but I cannot tell you how do I use that.
Okay, thank you. And I also just wanted to add one more thing about previous question. So I think, yes, you should generally take care about memory leaks in front end and think about, for example, markers on the map. This might be tricky, especially if you are loading content from the remote API, or if you are using some semi-auto-generated front-end code. For example, there used to be a framework, Meteor.js, which was like doing automated code generation for both the backend and the front-end. And especially there, if you are doing some hacky things, then you might have some problems with memory consumption on the front-end. So thank you very much.
Okay, so great applause.